My thesis topic is how to visualize a class diagram using OrientDB. Orient database is basically a NoSQL database. NoSQL is also known as non-relational and non-SQL. It has been used in 21st century in a wide range. Here it has been used in Facebook, Google, Amazon.com. Various other sites are also using NoSQL because it supports big data, which means to store a large amount of data in the form of petabytes, terabytes, and it supports four databases. First is key value data model. Here the data can be put for a key as well as deleted from a key, and here the key value always stores using primary key and a hash table which points to a particular item of the data. Then comes the column based data model. It is also RDBMS, which is a non-relational data model and has a well-defined structure which helps to decide the design of the database. Then document oriented, which is a semi-structured database, and it has CouchDB as well as RavenDB as an example, and it uses JSON, that is JavaScript format, for storing the database. Then comes graph database model, where the data is stored in the form of nodes and the relation between the two nodes is being depicted in the form of edges, and the relationships are written on the edges. The comparison between all these four databases in the form of performance, scalability, flexibility, complexity, and functionality has been depicted. Non-cap theorem, which supports NoSQL databases, it has consistency. That means whatever you will give the input, you will get the same as an output. Availability, that means 24/7 hours available, and partition tolerance means the system continues to operate even if a single system fails. OrientDB, it is a first multi-model open NoSQL databases, and it is a second generation distributed graph databases. It stores 20,000 records per second. These are the basic features of OrientDB. Then implementation, I have done my work in Eclipse using Java 8 because it supports various libraries of OrientDB. And here I have first of all created a Maven project by selecting a wizard Maven, and then automatically dependencies of pom.xml will be created in like this, and then I'll be creating a further collector classes. I'll be creating two collector classes, and then in that I'll be making the packages where I'll be writing my code. Then I'll be implementing it in OrientDB Studio. This is the OrientDB and this is the OrientDB Studio. Here I'll be running up some queries in this form, so that I can convert the class diagram in a graphical format like this. Here you can change the queries and match up with different packages. Here you can decrement, you can use, the queries are similar to SQL but are not exactly SQL queries. This is how the nodes are depicted without the edges. These are the nodes, and how much time the data graph takes to be built, and how many rows and columns are retrieved. This is depicted here. It is query is executed in 0.33 seconds. Then I created the function called split. I have splitted the different nodes in different form, and this takes times 0.145 seconds. And then I have selected to retrieve the class diagram. I selected from the query, and the users and the movie relationship is being depicted over here, and here each node is not related with one another. So this is how, and the change in one particular node will not affect the other nodes, so the class diagram will not be affected. This is the flow chart I have implemented to make the class diagram in the graphical format. Then conclusion, together NoSQL along with the Orient database, which supports both graphical and document databases, and the case study has been illustrated in my thesis work, and the relationship between the classes have been depicted through graph in OrientDB, and the performances have been noted down. Future work will be I'll be improving response time of a particular query. That's it. Thank you.